Tuberculosis is an opportunistic bacterial infection latently carried by about a quarter of the world's population, according to the NIH. Active tuberculosis accounts for roughly 1.5 million deaths per year, and data from the WHO shows that there were over 400,000 cases of multi-drug-resistant tuberculosis in 2022. The rise of multi-drug-resistant strains is making tuberculosis harder to treat now more than ever. To tackle one of the most deadly diseases in history, we must find new ways of dealing with multi-drug-resistant strains of tuberculosis, one of which employs the use of bacteriophages. Bacteriophages are viruses that infect and destroy bacteria by replicating inside of them and breaking them open. Previous clinical trials have shown the loss of active phage during treatment using devices such as nebulizers. Our lab is focused on creating a bacteriophage dry powder formulation capable of being aerosolized that increases the cellular uptake of a large number of active phage. We believe that changing the molecular size and concentration of polyvinyl pyrrolidone, a water-soluble polymer, in the formulation will help us optimize cellular uptake of bacteriophage. To accomplish this, my colleagues and I are using a novel thin-film freeze-drying technique. In this process, a liquid formulation carrying bacteriophages is frozen quickly in a dropwise fashion. The product is then filled into vials and dried in a machine called a lyophilizer. The dry pellets are filled into HPMC capsules and then put into an inhaler where they are sheared into a powder that is inhaled by the patient. Once in the lungs, the phage protected by the polymer reaches the alveolar space, where it is picked up by alveolar macrophages, cellular scavengers that pick up foreign bodies. Some of these macrophages may harbor latent tuberculosis that the bacteriophage can infect and destroy. We've had promising results so far and hope to move on to work into cells and animals later this year. Ultimately, our goal is to improve the efficiency of bacteriophage therapy to help mitigate the tuberculosis pandemic and inspire similar therapies around the globe. Thank you.